Okay, guys, I think we can start today's session. Okay, in the last session, we have been discussing about different concept of rows. Okay, we have discussed most of the concepts in rows. Maybe I will give an abstract of this concept for those who don't attend the session last session, and then we can start with some hands-on. Okay, very basic examples with rows. Then we will jump into the programming and also some rows tools, how to work with some rows tools and all. Then so we are actually going to start the next chapter, that is programming with rows. Before that, just go through the things that we have discussed in the first chapter, and then we will start with the second chapter. Okay. So in the last class, I have been basically discussing the concept like the rows nodes, which is basically each process running using rows API. Okay, basically like if you take the rows computational graph, each entity in the computation graph is a rows node, which is actually a process or a program running with rows APIs, okay, which is doing some computation. So that is rows node. And then the rows master, which is the broker program, okay, so which will help which will help the nodes to communicate with each other, connect with each other. After connecting, it will communicate with each other. And then I didn't talk about the parameter server. The parameter server is actually a program, okay, a program, and in that program we can able to store variables. Okay, so like imagine you have two programs, okay, two rows nodes, and these two rows node has to store some values globally, okay, or like it has to store some value, okay, and that value has to share by multiple nodes. Okay, so first node will store that value to the parameter server. Okay, and the second and third and other nodes can access that value. So it's like a global variable, like it's like a storage, and we can store different kinds of data to the parameter server, and any nodes can access that value. Okay, so you can set the privacy of the scope of the variable as public and private. So if it is private, then we can the nodes can only, one node can only access it, but if it is public, then any node can access it. So basically, when you start the rows core command, yesterday I have shown to you, so the rows core is actually starting rows master and also the parameter server. Okay, so the parameter server is actually starting along with the rows core. Okay, so then you can start storing the parameters into the parameter server. Okay, I will show you like how to store and get the values and all, but just understand what is the parameter server. It's just for storing different values, static values mostly. Like if you want to store like a PID value or something like a name, something like that, the values doesn't change much, you can store it in parameter server. And then rows messages, I think you already know, like the type of messages flowing through the rows topic. Okay, and the rows topics are like data bus, which is connecting like between two nodes, okay, or two or multiple nodes. Okay, it's like a data bus, and rows messages are passing through it. Okay, and rows action and rows service I discussed yesterday. It's like another kind of communication. Maybe I can just go through the topics. Topics is like asynchronous communication, like one node is continuously sending data to another node. Okay, or like it is just sending some data, maybe not continuously, or like maybe one by one or something like that, but there is no acknowledgement or some there is no like mainly acknowledgement is not getting from the other node. But row service is actually different. It's like a request response kind of communication. Okay, so if you want to like create a row service, you can able to create, and basically the working is one node is requesting to the other node to do something. Okay, then the other node will receive the request, and then it will perform the request, then it will send the results back. Okay, so it's not like rows topic. Rows topic is continuously sending the data. Okay, but row service is like getting a command, executing it, and sending back. Okay, so it is mainly using for like switching on, switching off kind of thing, or like enabling like maybe some part of the program. You can simply use the row service. Okay, like here the example is like calculating 2 plus 2, then it is sending to the other node, which is called the server, and server will execute it and sending it back. Okay, one problem with the service is that it will take time actually. Like once the request is placed, the client has to wait. Okay, the client node is one who sent the request. Okay, and client has to wait until the response getting from the server. Okay, the client and server is basically rows nodes only. So that is the problem. Okay, but it is mainly using for like simple application like switching on, switching off, enabling, disabling, some that kind of activity, saving of map, or those kind of things can be easily done using row services. Okay, so now the rows action. Okay, rows action is like a superset of row service. I can say like a superset of row service. Basically, the client and server is there. Then client can place a request. Then server will accept it, and then rather than like waiting, server can also send the feedback, the process feedback. Meaning, the client is putting a task to the server. Okay, then server is starting executing that task, and it will take some time. Okay, then server will send the feedback, how much the server completed the task, like that. Okay, so the client will get the feedback, and then after completing, the server will send the result. Okay, so the advantage of using rows action is that it's not getting, I mean, it's not about like only feedback. Imagine the client actually placed a request to the server, like count from 1 to 10 crore. Okay, so it placed the request, and the server is actually executing it, and then it will take time, right? And client is getting feedback as well. So when it count up to 1 crore, client decided to cancel it. Okay, cancel that task. So that is also possible with rows action. Okay, you can preempt the task, or you can just cancel the task and you can place a new task. Okay, so that is the flexibility of rows action. Okay, like preempting the task, and then you can send another code. So this rows action is using in the rows navigation stack. If you are like heard about rows navigation stack, like autonomous navigation in rows, it's actually that node actually using rows action. So you can send a goal position to the navigation stack, and the robot will going to execute the goal position. Before reaching the goal position, you can place another goal position, so it will cancel the existing one and go to the next one, like that. Okay, so rows action is very useful, but the thing is that like rows action is little difficult. Rows service is slightly easier than rows action, and rows topic is very easier. Okay, so the implementation is somewhat difficult. Okay, but you have to use rows action whenever it is required. Okay, so we will see the program like the server program and client program and all. So I was just concluding the first chapter actually. Okay, so I just want to know like if you have any doubts in the first chapter, basically like first chapter, or like in the rows concepts. Okay, so we actually need this much of things. Okay, and okay, so the rows action and rows service we have discussed, and another last topic is the rows bags. Okay, So I think I have given an idea about ROS bag, but maybe I can say it again. So ROS bags are very useful utility in ROS. Okay, very useful. So what happening is that when you send a message or when you send a data from one node to another, there is a data flowing, right? And then you can store this data. Okay, you can store this data. Okay, and you can save it as a file. Okay, so where we are using that, I can say an example. So this is a robot and there is a camera and there is a camera driver. So the camera driver basically reading the images from the camera and sending to navigation stack. Okay, navigation node. Also LiDAR and encoder. Okay, basically these three programs are reading the values from the sensor, right? So what we can do is you can use the ROS bags in order to save the data that is sending from camera driver to the navigation node. Okay, so LiDAR driver to the navigation node and encoder. Okay, so if we have this saved data, then you don't need this actual hardware to test. Basically, you can use that file and you can play that data and then you can give it to the navigation node. Okay, so then what we are doing is we are actually just removing the hardware, actual hardware from the picture. Okay, basically you need some test data for implementing your algorithm. So you may not need the actual hardware always to work on it. You just need the stored data. Okay, you may have heard about the data set and all, right? So ROS bag is actually creating a data set. Okay, and then you can play it and then you can process that data and then you can develop your software. This is very useful. Why? Because imagine I got a project there is a robot in UK and they will send the back file. Okay, they will send the back file and then I can open that back file in my PC and then I can process and create the robot application based on that back file. Okay, so I don't need to access the hardware, I just need the back file. So that is actually ROS bag, which is very useful. And so I think these are the important things that we have to discuss in the first chapter. Okay, now we are going to the last two things, like the example. Okay, so I'm just giving maximum 5 minutes for a discussion or like a Q&A. Do you have any questions regarding the basic concept of ROS, like the concept, computation graph? If you have any clarification, I will explain it again. Okay, then only we will go to the examples. Okay, so let me know if you have any questions. Let me know if you have any question. I can simply show the slide to you. If you have any question, you can just comment or like. Okay, I think we have covered most of the things. Okay, different distribution. Okay, right. So I think we have covered most of the things, and maybe I can just explain some other slide. Yeah, this may be useful as well. So if you just go to the ROS website, okay, just a second, you can able to see a list of robots that is supported by ROS. Not only robots, but also the list of sensors, okay, supported by ROS. Okay, just a sec. I think, yeah, it's in the ROS wiki. So you can find here robots, sensors, motors. Okay, so I just want to show this. Why? Because if you want to work with a robot that is fully supported or fully using ROS, you can just check this list. Okay, this list means the robot mentioned in this list is completely controlling using ROS. Okay, completely controlling using ROS. And these are the sensors. I mean, there are many sensors that is not in the list, but these are the sensors that is completely supported by ROS. Means you can simply plug these sensor to your computer. Okay, then you can start the ROS program to read this sensor data and convert into like ROS messages and send us ROS topic, send through ROS topic. Okay, so the driver, ROS driver program is available for this list of sensors, and also for the motor controller. Like if you want to control the motor from the computer, you can simply use one of these motor driver, and you can simply control using ROS. Okay, so I just included some pictures of some robots. The PR2 robot, which is fully controlled using ROS. You can think about the complexity. It is having 2 arms and multiple vision sensors, so it is completely controlling using ROS. Then the Turtlebot 2, 3, okay, and the 4 is also coming. And then these all robots like Pepper, Tiago, Reem, Baxter. Baxter is not available now, but all the robots. Pepper is having another software, but it's also support ROS. Then Robonaut, which is from NASA. Then Fetch Robotics, TalOS. I mean, these are some of the robots. Okay, then Robotic Arms, ABB Industrial Arm will support ROS. Then UR5, Kinova. Then Pioneer 3DX, which is a standard platform for mobile robots. Then Husky, which is a rugged outdoor robot. Then Fright, which is a robot from Fetch Robotics. Okay, so yeah, this is actually a demo video from Willow Garage. You can see this video from YouTube. Basically, these guys actually designing a robot application using ROS and some web technologies. The basic intention is fetching beer from the fridge. Okay, so you can simply watch it, and it's actually playing in 6x, so you can find how slow it is, but it is doing the job. Okay, so Karthik is having a question: does ROS support deep learning and ML? So I think you got an understanding. Like ROS is not about so supporting means you can include these deep learning APIs and everything on your program, and you can also include ROS APIs on your program. Okay, so that means ROS is supporting. I mean, and then basically like currently I'm doing a deep learning program from NVIDIA. So what happening is that NVIDIA is having some deep learning APIs, okay, for object detection and all. So basically what ROS does is that ROS actually taking images from the camera and sending as a topic, and this detection node will subscribe to the camera images, okay, then convert into NVIDIA CUDA format, and then do the detection, and then convert that detected image into again ROS equivalent. So currently I'm working on this stack. Maybe I can show you that. So it's completely using ROS and deep learning stack from NVIDIA. So it is for object detection. It will work with ROS 1 and ROS 2. I mean, even I'm working with Jetson Nano. It's completely, I mean, working well with good frame rate. You can use USB cam or USB. CSI cam, Raspberry Pi cam, or everything will be supported. So there are many framework, many packages that is using ROS and deep learning. Okay, so you can easily integrate all these things. Okay, so yeah, and these are some of the sensors. I mean, a lot of sensors are supported. I just included some basic sensor. Velodyne LiDAR, which is one of the popular LiDARs for self-driving cars. Okay, then many USB cams and then depth-cam. Okay, and IMU as well. Yeah, and also you can integrate, or you can add or connect some IO boards like Arduino, then Tivasi, all this board to ROS, and then you can interact with it. So I'm not discussing that now, but just understand that you can connect Arduino and ROS, but we will discuss in another chapter. Okay, so Kalpesh is having a question. So can ROS be interfaced with custom hardware? There is, yes, of course. However, ROS programming, yeah. So interfacing means, I can say what is happening with the interfacing. Interfacing means the ROS interface means like you can communicate with the hardware using ROS topics, ROS service, or ROS action. Okay, so basically you can write your own code for the custom hardware. Okay, and you can expose this ROS topic. So whenever you publish a ROS topic, it will be subscribed to the interface, and then interface code or interface application, and then it will do some job. Okay, so all these things are possible whenever you start with ROS programming. You will have a clarity. Okay, so most of the sensor, like if it is having an open source driver or something like that, then you can add the ROS APIs into it, and you can create publisher and subscriber. Okay, so whenever I'm starting with the programming, I will explain this, how it is, how we are doing it. Okay, yes, and ROS is having like support with lot of libraries, which is one of the benefit in using ROS. Like Gazebo is already there, OpenCV is already there, Point Cloud library, MoveIt, Navigation Stack, ROS Industrial, everything is actually there. Okay, so it's very easy to work with these libraries, and you can easily like convert the ROS messages into OpenCV data type, OpenCV data type to ROS messages. ROS is actually a communication framework, but OpenCV is a computer vision library. So OpenCV is having like some data types for holding the images and all. So basically using the OpenCV ROS interface, we can convert ROS ROS image messages into OpenCV data type, then vice versa. Okay, so we can do a lot of things using it. There is a chapter coming with OpenCV, PCL, and everything with ROS. Okay, and this is more important, and this is actually somewhat old. The thing is, when you learn ROS, what are the opportunities that you are going to get? So the limit is actually like very big. I mean, there are many companies now are working with ROS. Okay, I know Intel, AMD, then Nvidia, big players. Everyone is working on ROS in different domain. Nvidia, they are working on deep learning, then embedded, a lot of area. AMD is working on embedded. They have their own AMD actually acquired Xilinx, which is mainly famous for FPGA, so they are working on ROS 2. Then Reputer Robotics, BMW, everyone, most of the tech companies are like working on ROS. Okay, so that is very promising. Like when you complete this course, you will get job opportunities and also research opportunities. Like many universities are also preferring, because ROS 1 was designed for research, so a lot of universities are using ROS. Okay, so that's what the importance of this. And you can itself, you can check the opportunities in Glassdoor or like Indeed. I think in this website you can just check robotic software engineer or ROS developer, something like that. You will get a lot of opportunities. Okay, so regarding the future scope and all, what I have to say is that when computers invented, Microsoft actually created the operating system, and they are actually very successful. They are a commercial company, right? It's not free. Linux was also there. It was also a hit. So basically, computers, the popularity of computer actually mainly because of the software, I will say. Even Mac has their own operating system. So like that, for robot programming, ROS is one of the standard software, one of the popular framework that we are using, and it will become one of the de facto standard for robot programming. Okay, mainly ROS 2 is becoming. So learning ROS 1 and ROS 2 is not a waste of time if you are planning to work with robots. Okay, somewhere, sometime this will be useful. Okay, and if you are interested in learning, new concept, new packages or new things happening on ROS, I think ROSCon is one of the best opportunity. If you are a student, you will get scholarship. I think that time is over. The next ROSCon is happening in Japan, and I attended ROSCon 2019 Macau, and this is on the left side. You can see the CEO of Open Robotics, Brian Gerke, and this was one of the release of my book. So I had an opportunity to meet Brian. So like that, you can also personally meet these people, and then get updated with the ROS framework. Okay, so now I'm just switching to some examples. Okay, Hello World and TurtleSim. Then we can just start with the programming. Okay, programming basic. So the first example I just want to show you is the talker listener example. Okay, the objective of this session is what is actually going on, okay, when we start talker and listener. Okay, so the first thing you have to do when you start before running before any ROS node is starting ROS core. Okay, ROS core is the command you have to start before any nodes. Okay, so the ROS core is having parameter server and ROS master. So now I'm just starting a node. Okay, so when you install ROS, you will get some examples, pre-built example. So there is a package. Don't worry about the package. The node name or the executable name is Talker. So don't worry about ROS run. We are going to discuss that next chapter. So I'm just starting a node. Okay, just starting a node, and then in the next terminal, I'm just starting another node. Okay, called listener. Okay, so while working with ROS, you will have some confusion. Like some of you start ROS core, then in order to start next command, they will close ROS core and then they will execute the program in the same terminal. So I will prefer an terminal application called Terminator. Okay, Terminator. I'm just giving the command to install Terminator on your PC. Okay, simply like sudo apt install Terminator. Okay, so maybe I can show you that. So this is very important. This application will be we will be using most of the time. So just use the Terminator. Okay, it's again, yeah, but this is a command. Okay, this is a command. Then you will get the Terminator, and then you can, after installing, you can able to search for the Terminator, and you can see this. And the basic functions are like just press Control and just scroll the wheel of the mouse. Then you can zoom the Terminator font. Okay, and if you want to split the terminal, just right click and you can find split horizontally and vertically. Okay, just right click and you can find and split horizontally, so the entire Terminator screen split into two. Then if you want to split into vertically, then this will be split into two. Okay, so like that you can create multiple terminal, and this is what we require while working with ROS. And in order to close any terminal, you can just press Control D. Okay, then that terminal will go. Okay, so just start row score, then talker, listener. Okay, so let's see the computation graph. Okay, so we have ran two nodes, and then we can see what is happening in the background. What is happening? So basically, this is what happened. Okay, this is the computational graph of currently running nodes. Okay, there are two nodes. We ran two nodes. One node, the name of the first node is talker, and the name of the second node is listener. Okay, and what is these guys doing? Like the talker is publishing a topic called chatter. Okay, I mentioned that the topic is a named database, and the name of this database is called chatter. Okay, and then talker is publishing. Okay, so what is listener doing? Listener is subscribing to this topic, meaning receiving data. Okay, so I think I have mentioned how these how the connection between talker and listener or any node is happening in rows. It is because of the rows master. Okay, so rows master will get the idea of two nodes, and then they will exchange the information. Rows master will exchange the information, and then they will connect with each other. Okay, so this is the computation graph, and you can able to see the talker is actually sending some data, and that is actually printing here hello world 1063, and that is actually receiving here. There is no latency or something like that. It's very fast. Okay, so whenever I stop talker, listener already stopped. It's not stopped, it's just paused because it's not getting any data from talker. So when I start talker, listener again started. Okay, listen, in the sense it's actually start receiving the data from talker. Okay, and then we can check what is the kind of data that is flowing through chatter. Okay, so it's a string data. Okay, no need to worry about the commands, I will explain it after. So it is the string data, and it is publishing by talker node, and it is subscribing by listener node. Okay, so it's a string data, and if you want to check the data flowing through the chatter topic, you can simply get this. It's like tapping the database. Okay, you are simply tapping, and you can able to find the same data that is going through the listener. Okay, I mean, this is what happening in the rows topic. I mean, a data is flowing, and you can tap the data like this. Okay, even you can tap it in tapping means you are simply subscribing to that topic. Okay, so like these two things are nodes which is subscribing to the chatter topic. So if you just check the computation graph, you can able to find this. Just a sec. Okay, just a second. You can find the talker is publishing. Okay, talker is publishing chatter, and then chatter is subscribing by listener, and also rows topic node and another rows topic node. Okay, and also this can happen another combination. Maybe I know there is a topic called chatter, right? So I can manually publish a data to the chatter topic. Okay, make sure the type of data should be same. Okay, and the data flowing through it doesn't matter, the type actually matters. Okay, so currently you can able to see into the chatter topic two nodes are sending. Okay, so this is what I think you got the idea. Like, there is a data bus, only one type of data will go through that data bus, and any number of node can send data through this data bus, no problem. Okay, they can use the chatter bus and they can send string data. Okay, and any number of nodes can subscribe to it. Okay, so that is what the ROS topic is. Even I can do the same thing. Okay, just a sec. Okay, so there is 3 nodes sending different data to the chatter topic. Okay, type is same, different data actually. Okay, and we can see what is listener is getting. Oh, okay. Oh, I accidentally closed one tab. Just a sec. So let me see what are the nodes active. Okay, I think okay, that is fine. You can find the messages are like coming like lentin 123 lentin. It's actually coming one by one sequentially. Okay, so through this database we can actually many nodes can send the data, many nodes can subscribe to the data. Okay, so this is what the first example, and we will see the code. Okay, we will see the C++ and Python code to create a subscriber and a publisher. Okay, so that will be the first thing that we are going to do. Yeah, so I think you got an idea about this example, right? If you have any question, let me know. Any question regarding the example that I have shown to you? If you don't, then I will jump into the next example, which is the turtle sim. Okay, so if you like gone through some tutorials in ROS, you might see a cute simulator called turtle sim. Okay, so the turtle sim is the it's a 2D simulator, okay, in ROS. And what is the intention of this simulator? The simulator is actually for learning ROS. Okay, learning the concept of ROS. I think most of the concept you can learn it from this simulator. Okay, like practicing. Okay, these command line tools, GUI tools, then concepts, everything should be cleared after lot of practice. Okay, currently maybe I can remember a lot of command line tools, but for you it will take time. Okay, it will take time. So in order to practice, actually turtle sim is a good tool. Okay, very good tool. There is no specific application for turtle sim. Okay, only intention, the main intention is learning. Okay, and what is inside this simulator is very simple simulator. So what it is having is, it is having a turtle, okay, which is basically a robot. Okay, and the robot is actually in a 2D plane. So like imagine a robot is placed in a floor is actually 2D, right? So you can able to move the robot by giving speed commands. Okay, so basically in order to move a mobile robot, you have to give two kind of velocity to it. Okay, two kind of velocity, which is linear and angular velocity. So the linear velocity is driving the robot forward, okay, and angular velocity is giving the angular displacement or the twist, or like it will do the deviation, but linear will only like going forward. Okay, so the combination of linear and angular will move the robot in any place. Okay, so the input of the turtle sim and output of the turtle sim is actually like given in the website, in the turtle sim website. Okay, so I'm just explaining this because the initial projects that you are going to do with ROS, maybe you can use turtle sim. Okay, just a sec. So I'm just sharing the link. Just a second. So this is the turtle sim tutorial, or like wiki page. So it is having almost all the information, and there is a tutorial for turtle sim. Okay, so mainly we are using these tutorial. Yeah, here you go, the tutorials of turtle sim. Okay, just a sec. Okay, so basically I can just show you some of the project that is done using the turtle sim. Okay, so I actually like mention them, like you can use this tool in order to learn. Okay, and from the first batch, actually most of them created some interesting examples, like ping pong game using turtle sim. Okay, I didn't imagine the creativity. Okay, I'm not giving the ideas, they only actually coming up with the ideas, and yeah, they're implementing. So I mean, here what we are doing is like there are three robots. Okay, three turtle in the form of turtle, and you are just playing with these three robots. Okay, and just see this, I actually given some input for this, but this is using the OpenCV as well. So here you can give an Iron Man image, and then the real image and the Iron Man image will be like converted into like edges, and then a swarm of turtle will draw that image in the turtle sim. Okay, so these kind of interesting examples you can work it. Okay, I know mostly like if you not practicing using turtle sim, you can't able to understand the higher level concept. Okay, it's not like I mean, after hearing my lectures, it will not completely help you to understand all the concept. You can only study by practicing. Okay, so yeah, so these kind of interesting examples, I think I can give the link to you, you can just refer. So maybe you can start it using the turtle sim. Okay, then you will understand the difficulty in working with ROS or ROS programming. Okay, so after working with this simple project, then you will get a confidence to work with the bigger project. Okay, it's not very easy. Maybe some of you directly work with navigation or something like that, but that is just a tip of iceberg. Okay, in order to start programming, there are a lot of things to do. Okay, yes, so I'm just starting with the turtle sim, just showing there is a simulator called turtle sim, and it's already inbuilt on ROS. Okay, no need to install. Yes, and this is the installer. I mean, it's a simulator. Okay, you can able to see, right? So using these turtle sim simulation, you can able to understand topics, how the topics work. You can able to understand services, okay, and parameters. Okay, so here are the list of topics that is subscribing by turtle sim simulator. Okay, so it is subscribing to the command velocity, meaning the linear and angular velocity. Okay, so the input is the command velocity. So whenever we give a command velocity input or like some velocity to the turtle sim in this topic, using this ROS message, the robot will start moving. Okay, and when the robot moves, it will publish the position of the robot. Okay, so that is what the turtle sim is publishing, the position. And then in order to like clear the robot or reset the robot, we can use the services. Okay, so that is where we are using that is using the services, ROS services. Okay, and there are some parameters as well in order to like set the background color and all. So okay, so I can just show you how it is working. Okay, no need to worry about the commands. I will be discussing in the next chapter. So I can show you like the turtle moving. So basically I am using some nodes, okay, already in the turtle sim package or turtle sim, yeah. So you can see I'm just moving the keyboard. So this program, what happening is that this program will read my keyboard arrow keys and then convert into velocity commands, okay, and then publish. Okay, so then the turtles will move. Okay, so you can see when the turtle move, the turtle is having a pen under it. Okay, so when it moves, it will draw a line. Okay, so you can find, you can just rotate it and then you can move it. Okay, just forward and rotate. Okay, that is what most of the differential drive robot can able to do. It can't move to move in the y direction. Only the omni wheel can do it. Okay, so it's a kind of differential drive robot, and it's moving in a plane. Okay, so yeah, so I'm just showing you the computation graph. What is happening now? Using computation graph, we can easily understand. Okay, so here is what happening now. Like this is a ROS node. Okay, turtle sim is a simulator and basically it's a ROS node. Okay, and what is happening is that I started a node called Teleop turtle. Okay, Teleop turtle, and this Teleop turtle is publishing a topic called turtle1 command velocity. Okay, and this is the topic that is subscribing by turtle sim. Okay, so you can able to see the values coming or flowing through this topic. Command velocity. Okay, and whenever I move, okay, you can able to see the linear and angular velocity is getting published. Okay, so linear velocity in x direction and angular velocity in z direction is only we are using because it's moving in a plane. Okay, so this is what happening. This is the computational graph currently. Okay, currently the computation graph is this. Okay, and maybe in parallel you can run another node, like maybe I can run Talker. Okay, let me run Talker. So you can run multiple nodes. That there is no limit, only the memory is the limit. Okay, memory and the processor. So I can start the listener. Okay, and we can check the computation graph now. So here you can see two graph. Okay, because these nodes are not connected, right? Like the first graph is showing the talker and listener. Okay, and it's not connected to the Teleop or the turtle sim. And the second graph is basically like the Teleop turtle is publishing this velocity and TurtleSim is subscribing to it. Okay, and another node is again subscribing to it. Okay, so this is what happening in background. So knowing the computation graph will help you how the nodes are communicating. Okay, so it's very easy to debug. Okay, so I think we can start with the next chapter. This is just an introduction of TurtleSim. In order to understand how to start TurtleSim and how to work with TurtleSim, you have to understand the ROS commands, ROS tools and all. Okay, so that I'm planning to discuss next. Okay, which is actually the part of programming with ROS. Okay, so make sure you have ROS installed, okay, on your computer. And if you are ready to work with ROS, then only this session will be useful. Okay, maybe from next week I think I can start with the commands, because it's already like 9:51. Maybe I can let me see whether I can okay, almost all the topics will take time. Maybe I can start with very simple commands. Okay, so if you have ROS installed, you can just try. Okay, then next week I will be like discussing almost all the ROS commands, and this is very, very important. Okay, this is very, very important. So just install Terminator if you have, or if you don't have the ROS setup, just see what is going on and then you can try it later. Okay, so first I'm going to show you the list of command line tools available in ROS. Okay, I mentioned that in the ROS framework there are 4 things: plumbing, tools, capabilities, and ecosystem. Okay, so the tools, the second thing, is what we are talking about now. Okay, the tools are mainly for visualizing, debugging the computation graph. Okay, so the computational graph means ROS topic, nodes, everything related to the computation graph. Okay, or the part of the computation graph. So I am starting 2 nodes. Okay, I'm starting 2 nodes, that is talker and listener. Okay, talker, the sample, so the talker and listener. And just a second. Actually I have started 2 nodes, right? 2 nodes, and you know how to start the computation graph. Okay, don't worry about the command. You have seen the computation graph, right? So now I just want to inquire. So this is actually a graphical tool, right? It's a graphical tool. Okay, so using command line, how to check this computation graph. What are the different nodes? Okay, what are the topics? Okay, what is the message? Okay, what is the message type? Then who is publishing, who is subscribing? Okay, all this information you can get it from command line tools. Okay, so in ROS, actually, if you just type ROS and then press tab key twice, you can able to find this much of command line tools. Okay, this much of command line tools, very important. I can start from ROS run. Okay, I can start from ROS run. So in order to learn each command, just type the command. Maybe some commands will have help. Yeah, I think if you just simply type ROS run and enter, you will get a usage, okay, which is not very easy to understand, obviously, but there is a small description as well. Okay, you just try to understand, like a rows run will locate package and try to find an executable name executable in the package. Okay, that is also not very friendly help. Okay, I can explain. So the rows run command, okay, command line tool will basically start an executable. Okay, so executable means when you program in C++, when you compile, you will get executable, right? Or if you are working with Python, the program itself is the executable. Okay, so using rows run, you can able to run an executable. Okay, which is a rows program. I mean, which may be compiled, or which is a Python code. Okay, so in rows we are keeping the programs in a thing called packages, rows packages. So all the programs are keeping under packages. Okay, I will explain about package in the next session. So what I am trying to do here is the rows run command will help you to run a node, and I'm just using this command, and I can explain what is happening. So rows run space rows py tutorial. Okay, so this is a package actually which is already comes in rows. Okay, it's an example tutorial package. Okay, which is we will get this package when we install rows. Okay, and inside this package there is a Python program called talker.py. The same thing, same as the talker that we have discussed here. So in order to run it, you can simply use rows run, and if you press enter, you can able to see the talker is running. Okay, talker is running, and we are already starting we are already started another talker, right? We already started a talker, and so two talker nodes are running. Okay, two talker nodes are running. Let's check the computation graph. So what is happening in the computation graph? You can able to see two talker are working. Okay, so first talker name is talker, but the second talker name is talker space some numbers. Okay, so these two names are not equal, but it is publishing the same thing. Okay, so the problem with the nodes is that there will not be two nodes which is having same name. Okay, if two nodes having same name, one node will shut down. So that's what happening in rows. Okay, so in order to explain it, you can simply use this thing, rows CPP tutorial. So we have been running the CPP example. Okay, so currently you can see the name of the node is talker and listener. Okay, so if I run the second second node, same node, okay, same node, then what happening is that this node will shut down. Okay, because you can see the reason: shutdown receive, request receive, reason given for shutdown, new node register for the same. Okay, so the thing is that you can't execute two nodes at the same time. Two nodes means nodes having the same name. Okay, so in rows there are techniques to avoid this issue. Okay, there is a thing called anonymous, which is actually add a additional number, so then two nodes will not be same. Okay, so if you want to like uniquely assign a name, that is also possible. You can just set that anonymous is equal to false. So whenever two nodes, the same two nodes are started, one node will shut down. Okay, only one node will be working. So the Python program that you have seen was as anonymous program. Okay, so that can start Just a sec. So we will get the rows py tutorial and rows CPP tutorial. So the rows py tutorial, it's actually using an anonymous node. So you can see here 2 tokens are running, same program, okay, with an additional number. Okay, so that will differentiate the token node. Okay, so the same node, but it's different. I mean, same node, but executing in different names. Okay, so that is possible, but same node, same name is not possible. Okay, so I hope you got an understanding. So the rows run mainly for running an executable inside from a package. Okay, so the syntax is simply rows run, package name, and then executable name. Okay, so you can easily work with this command using tab. Tab is a very powerful tool while working with rows. So simply run rows or press tab once. Okay, then it will autocomplete. Then in order to find row CPP, you can just type row CP and press tab, then tab twice. It will give the packages with that name, then you can autocomplete. So tab is mainly for auto completion. Okay, and also I can just type and press tab, then it will autocomplete. Okay, it's not only useful in rows, but when you work with terminal, it will be very useful. So enter and it will run. Okay, rows run. Okay, is what the first command that we have explained. And then another command, useful command, let me check. Rows run we have seen. Okay, rows topic. Okay, rows topic. So the rows topic is a command line tool in order to work with topics. It can get information, almost all information about topic. Okay, so you can simply type rows topic on your terminal, press enter, then you will get a good tutorial. I will say good tutorial. It is having a good explanation, like rows topic is a command line tool for printing information about rows topics. Okay, and you can use these arguments with the rows topic command, like you can find the data flowing through a topic using rows topic echo. Basically, if you give rows topic space echo space a topic name, okay, then that data will be echoing. Or if you just use this rows topic list, then what is it giving? List active topics. It will show what are the active topics available now. So one is chatter, and these are like topics from the rows score. Okay, so you can able to see the chatter topic here. Okay, and whenever you do rows echo, then what will be the output? You can able to see the data flowing through the chatter topic. Okay, so this is the data flowing through the chatter topic now. Okay, so this is what happening, and you can press the Control C to cancel. Okay, it will close. So in order to explore other command line argument, I think rows topic echo is very useful. Rows topic list is useful. Then rows topic pub, rows topic info is again useful. Okay, info means if you just type rows topic space info space a topic name, it will give you what is the type of data, what is the rows message of that topic. Okay, so the chatter can only handle string data type. Okay, string data type. And who is publishing it? The talker. Who is subscribing to it? The listener. Okay. So you will get almost all the information from the roast topic info. Okay. And there is another command, okay, which is very useful, which is the command line tool for roast graph. Okay, a roast computation graph. There is a command called roast graph. So when you type it, you will get the detailed list of nodes and its services, its subscriber, everything. Okay, it's a command line way of finding things. Like here we have yeah, you can able to see it is continuously printing, so we can able to see there is listener node. Okay, listener node and inbound, outbound. It's I mean slightly difficult to understand, but like you can able to get some information like what are the services, then what is the topic, I mean in which node it is got connected. Okay, so I mean these kind of information can be easily tackled using roast graph, but I will prefer the graphical computation graph. But if you are like if you want to check with the command line, I think that roast graph will help. Okay, I think we can just conclude for today. Okay, let me know if you have any question. Okay, so next session we will be like discussing about the command line tools. Okay, then we will be like discussing workspace, the packages, then these the programming part. Okay, programming part, creating a package, writing a C++ roast code, Python roast code, then working with TurtleSim, all those stuff. Okay, so let me know if you have any question in today's session. Any question, guys? I think we only discussed the basic stuff. So if you have any question, you can ask. Also, you can just practice like these roast commands. You can simply experiment with it. Okay, so before next session, you can able to understand most of the things. Okay.
So, which roast package should I install?
Can you repeat? I didn't get you.
Which roast package should I install? Like I missed a couple of packages.
Okay, yeah. So it's very simple only. Like maybe I can upload the session. You just need to install the roast desktop full. So roast Noetic, just go to roast Noetic and then you can able to install this one. Okay, roast Noetic full. So it's already mentioned in the previous class. So if you have doubts, you can just refer it. So the desktop full is the package. That's it. Okay.
Yep.
Okay.
Yeah. Thanks.
So yeah. So any more confusion, guys? Okay, so if you don't have any question, then we can conclude today's session. And tomorrow, I mean next week, we will be like working with the command line tools and then programming and TurtleSim. Okay, working with the TurtleSim. So that is the plan. Okay then, guys, thanks for joining, and then see you next week. Okay, if you have any question, you can ask in the Discord. Okay then, bye everyone. Bye. Good night.